slide projector that consists of a single converging lens. The slide has an illuminated region of 2 centimeters by 2 centimeters, and the screen is 10 meters from the lens. Part A asks, should the lens be put into the projector upside down or right side up, i.e. is the image inverted? So this can be answered pretty conceptually. We know that the image formed is a real image as it can be projected onto a screen. And with these converging lenses, real images are always inverted, so the slide has to be put in upside down for the picture on the slide to appear right side up. And this is going to be shown later on, or confirmed later on, with a lens drawing. Part B asks, how far from the lens should the slide be placed so the image has a size of 2 meters by 2 meters, assuming the focal length of the lens can be chosen to make the image in focus. So we know here are the dimensions of the initial object and final image, and we also know S prime, which is that distance of the image to the lens. And B wants us to solve for S. So we can use the magnification equations that you see on the left, equating h prime over h to s prime over s, and rearrange so we're solving for s. The tricky thing here is, of course, just always remembering to make sure your units are all the same, remembering to change 2 centimeters to 0.02 meters to get that correct value of s. And s comes out as being 0.1 meters. So that's that distance that you want the object to be from the lens in order to get that final image of 2 by 2 meters. Part C asks, if the focal length of the lens is 0.099 meters, will the slide be in focus on the screen? Explain. So what you can do is you can solve for that ideal focal point and see how close it is to what the focal length of the lens is. And doing that, just using our classic lens equation, rearranging it so we just get F, we get a focal length of 0.099 meters approximately, which is pretty much identical to the value that they gave us. Of what the focal length of the lens is. So that means in this case the lens will be in focus. Part D asks, if the focal length of the lens remains fixed at 0.099 meters, how far from the lens should the slide be placed in order to make a sharp image if the screen is moved to only 2 meters away? So in this case what we know is the focal length and S prime, and we're solving for S. So once again, we can just use that lens equation, but this time rearranging to solve for S. Always keeping in mind that in this case, since we have a converging lens, our focal point is positive. And once we do that, plugging in our numbers, we get an S value of 0.104 meters. Part E asks, how big will the new image be in this case? So what we're going to have to do first is use the S values to solve for the magnification and then apply that to the dimensions. So we know that we know S prime and S, so all we have to do is plug those in. Keeping in mind that the negative just means that our image is going to be inverted. And we get a value of 19.23. And once we apply that to the height, multiplying the original 2 centimeters by 19.23, we get new dimensions of 38.5 by 38.5 centimeters. So that's how big the new image is in this case. The last thing I just wanted to show was an example lens drawing. This, obviously the dimensions aren't quite right on this, but it's a situation that's somewhat similar to what's described in this. You can see that the image is much larger and also inverted, which confirms what we got in the problem. So yeah, there's a few tricky parts in this, making sure you always have the right units and making sure you understand what values in the problems correlate with things in the equations can be kind of tricky, but once you really write out all the numbers you have, it becomes more clear. But yeah, that's it. Thank you for listening.